Okay, students, let's go over your practice test. All right, so notice number one here, because the coefficient is negative, I moved it to the other side to make it positive, so I'm never having to divide by a negative, which means then the constant is moving across. 6 minus 12 is negative 6. Last step, divide by 5. Being that I'm always dividing by a positive, I never have to worry about switching the inequality sign. Okay, because I'm always going to make the coefficient I'm solving for positive. When I move it across, add it across, that is the switching of the sign itself. But you're not actually thinking of that's what you're doing. But that's what's actually occurring. All right, number two, this coefficient on the x is 1/3, so it's positive, so I'm going to leave it there. So I'm adding the 7 across. 7 minus 5 is 2. And last step, multiply both sides by 3, and I get x is less than or equal to 6. Number three, again, the coefficient is positive, so I'm going to leave it there. Multiply by 4 on both sides. Okay, so 5x minus 3 is less than or equal to 8. Add the 3 across, 11, and last step, divide by 5. Again, I'm dividing by a positive, so I do not switch the inequality signs. Number 4, graph that. Y is less than or equal to 3, so it's equal to, so it's a solid circle there, 3 and below, or y is greater than 4, since there's no equal sign, it's an open circle at 4, and going to the right. 5, we got a closed circle at 6, less than that, and open circle at -1 and greater than that. So it's shaded in between. You cannot have arrows inside of there, or it's wrong, because an arrow means it goes on forever. Number 6, go ahead and write what it says here. It's an open circle at -2 going to the left. So x is less than or equal to -2 right there. Or, and another way to know it's an or, if it's going in opposite directions like this, is always an or. It cannot be an and. The word and is always used when it's shaded in between. So this is an and right here. If I was to split those up into two individual ones, it'd be k is greater than -1 and k is less than or equal to 6. When it goes in opposite directions, it's always an or. And so the other one we have is at 1. It's a solid circle. X is greater than or equal to 1. Okay, solve and graph the number line on the number line, the inequality below. So remember, we have an absolute value where we always have two equations or inequalities. First one, you just take off the absolute value and solve. So that's what that is right there. And if it's a greater than sign, remember we say greater, so we put the word or in between, which means it should be going in opposite directions. Okay, and the second inequality, I switch the inequality sign, so it becomes less than or equal to, and I take the negative of whatever is on that right side, or the opposite, same thing. And so last step, add the 3 across, and x is less than or equal to 0. And then I go ahead and graph that. Close circles because it's got the equal sign. Number 8, again, absolute value, so 2 answers. Okay, whenever there's an equal sign, it's always or. Okay, in between. First one, just take off the absolute value and solve, which is on the left side here. And so p is 0. The right side, the right second one, we make it -6. So that's what you see right here, and then solve it, and you get p equals 6. So your answers are 0 or 6. So I go ahead and put in 0, 6, or 6. All right, number 9 and 10. We're using the box and whisker to analyze the data here. What percent of the data in plot A is above 65? Well, there's 65, and we know that's 25, 25, and 25 for a total of 75. What percent of the data is below 85? 85 is right here. What percent is below? 25, 50, 75%. Okay, they're always in force. Number 11, graph the system of inequalities. We see that there's no equal sign on either of them, so they're both dashed. Okay, and then this one says less than, so that means below, shade below it. And this one says greater than, so shade above its line. And then we're just graphing the lines. Both of them are in slope-intercept form, so plot the y-intercept 4, and it's a slope of 1, so up 1, right 1, or down 1, left 1, and it's dashed. Second one, slope or y-intercept is -4 with the slope of -1, so it's up 1, left 1, up 1, left 1, up 1, left 1. Okay, or down 1 and right 1, down 1. Okay, and it's dashed as well. Okay, that's a dash. Okay, can't tell. So it's above this second one, which is up here, and it's below the top one, so it's right in between here. And again, I could check a point in that region. Easiest one to check would be 0, 0. I plug in 0, 0, they both become true. 0 is less than 4 is true, and 0 is greater than -4 is also true. So if they're both true, you have shaded in the right region. So there is no excuse for not getting this correct. Number 12, solve the system equations below. So we're going to eliminate their standard form. The two easiest points, in standard form, the easiest one to use is elimination method. And so I'm going to look to see, can I multiply one of the equations by a number to counteract the top one. So I have -1 here. If I multiply by 2, I get -2. That will cancel with a positive 2x. So I'm eliminating the x here. So multiply the entire bottom equation by 2 and add it to the top. And then I get 2 times -4 is -8 plus 2 is -6y, and -8 plus 8 is 0. So y equals 0. Then I go ahead and plug that 0 into one of them. I can just plug in right there. I get 2x equals 8, so x equals 4. If I want to guarantee I'm right, I would plug it into the bottom equation, and it would also be true. Y is 0, and x is 4. -1 times 4 is -4. So it works in both, so it's guaranteed to be right. Again, there's no reason for you missing this if you're checking your answers. 13, we have it set up for substitution nicely because it's solved for y. Sometimes I can substitute -4x plus 2 into that y right there. And don't forget, whenever you substitute in, you put parentheses around it. Then I go ahead and distribute, and I get that right there. Then I combine like terms. I end up with -3x plus 4 equals 9. Subtract. Well, so again, I'm solving for x, that's negative, so I moved it over to the right side, which means move the constant to the left. 4 minus 9 is -5 equals positive 3x. Last step, divide by 3, and you get -5/3. That's the x coordinate. Now I need to take that and plug it into -5/3 and plug it right into there, which then I have that written right here. Okay, to get the y coordinate. So I have -4 times -5/3 is 20/3 plus 2. I want to get a common denominator of 3, so 2 equals 6/3. So I have 20/3 plus 6/3 is 26/3. If I want to guarantee I was right, I'd take and plug both those back into the bottom equation and it would work out. Okay, next page. Polynomials now. First one, we're just combining like terms. Okay, so you got to remember negative is a positive. I had a negative outside of here, so that means switch every sign inside, but I just get -1 through there. Okay, and so that's why you see these written like this. I switched signs. Okay, combine like terms. 6x squared plus 5x squared is 11x squared. 7x minus 4x is 3x, and then 7 plus 4 is 11. Okay, next one, we are multiplying. Okay, you can just do 7 times 2 is 14x squared there. Then I have a 16x minus a 7x is 9x. And lastly, I have -1 times positive 8 is -8. You would have learned that it's just double distributive property, but it's also called FOIL because in FOIL only works with a binomial times a binomial. That's why I never say the word FOIL. You better say double distributive property or just multiplication of binomials. Number 16, we have binomial times a trinomial. That is worked out right over here. Okay, and I'm using the vertical method. Okay, -6 times -7 is 42. -6 times 5x is -30x. -6 times -5x squared is 30x squared. Then I have 7x times -7 is -49x. 7x times 5x is 35x squared. And 7x times -5x squared is -35x cubed. And then I just multiply, I'm going to add straight down, combining like terms. Okay, I already have the terms lined up beautifully. Just add straight down, it's just integers now. And there's that answer. 17, I'm just cubing. I'm distributing this cubed through all of them. Okay, so 2 cubed is 8, and then when I have a power to power, you multiply. So r cubed is r to the 9th, and s to the 5th cubed is s to the 15th. 5 times 3 is 15. Here, I just have two terms being multiplied together. I just add the exponents of like bases. So v and a v, add them. 8 plus 6 is 14. A w and a w, 7 plus 5 is 12. 19. In this one, I have an r to the 5th here. It cancels out with the r to the 5th here. That's why you see that. And you have an s to the 4th and s to the 4th. All cancel out. You're not going to have that on your test. It's just randomly generated like this. Now, you would just look to see where you have more r's or more s's and how many more you have. And that's where they go, either in the numerator or the denominator. And then lastly, negative 24 divided by 4 is negative 6. Scientific notation, remember, I go ahead and put the decimal. It's got to be between, the number has to be between 1 and 10. And so that's 7.55. And then I count back how many places to get back to the original spot. I have 4 zeros plus one more is a total of 5. So I'd have to go back 5. So that's why it's 10 to the negative 5 to get back to its original spot. The degree of the polynomial, remember that only is on counting up, adding the exponents on variables only. So 7 plus 4 is 11 for that term, 7 plus 2 is 9 for that term, and 1 plus 3 is 4 for that term. So the degree is always the highest one, 11. Product, we're just squaring a binomial. The shortcut is to square the first term. So 4x times 4x is 16x squared. To get the middle term, I multiply these two together. It gives me negative 12xy, and double that, negative 24xy. And last term is I square the second term. Negative 3y times negative 3y is positive 9 squared. It's always going to be positive because you're squaring it. If you don't memorize the shortcut, then you just work it out. Vertical method, 4x minus 3y times 4x minus 3y like we did above, and multiply that and you get that answer. All right, 23 through 27, we are factoring. Okay, so the first step in factoring is to factor out the GCF. The GCF of 108 and 27 is 27 itself. If you're not sure, take that number and divide it into on your calculator. 108 divided by 27 goes 4 times. So I take that out, and then I'm left with, I divide each term by that 27 I meant that I took out, and I'm left with 4x squared minus y cubed. Okay, that is not a difference of squares because that's a cube there. If that was y squared, then I'd be able to factor that further with the difference of squares, but it is not. All right, 24. I look for what two numbers, since this coefficient is 1, what two numbers multiply to negative 28 and add to 3. And that would be 7 and negative 4. So what multiplies to x squared, x and x, and then I have a plus 7 and a minus 4. Okay, for that. 25, again, factor out the GCF. So that's 6. I'm left with 3y squared plus y minus 2. Then I factor what's left inside parentheses if possible. That does factor. Okay, remember AC, 3 times negative 2, it multiplies to negative 6 and adds to 1 right there, the B. Okay, so what is that? That's 3 and negative 2. Multiply negative 6 and add to 1. So that's why you see 3y. See, it has to multiply the first terms, has to multiply 3y squared. So I have a 3y and a 1y, gives me that 3y squared. Okay, now these two right here have to multiply to one of these two. So I already have a 3, so it's going to be 3 times positive 1. And then this one times that one has to multiply to my other number, negative 2. Since that's a 1y, this has to be a negative 2 right there. Okay, and of course, if you want to check it, you can multiply it back out and it would be correct. All right, 26, I can see this as a difference of squares. Our square is a perfect square, 16 is a perfect square, and there's my difference sign. Don't forget, I could rearrange that and say r squared minus 16. It might be easier to see. And then I take the square root of each, r and r, 4 and 4, and one's a plus and one's a minus. Wipes out the middle term. Okay, 27, factor out. Well, so one thing, I would factor out GCF if there is one, there is not. Since there's not, the other thing I want to look for are both the first term and the last term perfect squares. If they are, then that's a good sign. It's going to be a perfect square trinomial. So 25r squared is a perfect square, and 81t squared is a perfect square. Square root of 25r is 5r, and the square of 81t squared is 9s. So the question is, how do I get that minus sign as opposed to plus? I look at this middle term right there. So that's a minus, that's a minus there. If it's a plus there, it'd be a plus there. So if I multiply this out, 5r minus the quantity 5r minus 9s squared, that would give me exactly this right here. Okay. And last one, solve the quadratic. All quadratics, when you solve a quadratic, in order to solve it, it has to be an equal sign. There's your equal sign. It's a quadratic because it's degree 2. Okay. Solve the quadratic. First step you do with all quadratics is set equal to 0. I want my a, the coefficient of the quadratic term, to be positive. So it's positive already on the left side, so that means I'm going to move this across. So it makes it minus 9w equals 0. That's step 1. Set equal to 0. Step 2, factor out the GCF. The GCF is w. Then it'll left me with w minus 9. And then third step would be factor what's left if possible. That is not possible to factor, so that's done. And then last step, when you solve, is you set each of these factors, that's a factor and that's a factor, equal to 0. So w equals 0 or w minus 9 equals 0. And then you get your answers of 0 and 9. Okay, and so now you've got everything explained. Test next class.